Okay, this is lesson 24, logical thinking. So solve each of these problems first, and then we'll go over them. So hopefully this is a little bit of a review from what we've been doing. 352 divided by 352 divided by 11. So I'm going to do it using the 7 method. But whatever method you pick is fine, as long as it works. So I know 11 times 11 is a math fact that I know. It's 121. That's the easy one to remember. So then I subtract. I get 1. So I get 231. I'm going to do another 11. So it's another 121. So I'm left with 0, 1, 1. And that's 11 times 10. So when I add these together, I get 11 plus 11 is 22, plus another 10 is 32. 421 times 15. So 21 times 15. So I get 4 times 1 is 4 with 3 zeros. I better make some lines in here, so I can keep track of everything. 20 times 10 is 2 with 2 zeros. And 1 times 10 is 10. 5 times 4 is 20 with 2 zeros. So when I do 5 times 400, and I get the 5 times 4 is 20, I still need to tack on these 2 zeros. So I end up really with 3 zeros, but only 2 of them are from this number. 5 times 20 is 100, and 5 times 1 is 5. So when I add those all together, I get 6,315. Okay, 3/8 plus 1/24. So in order to add two fractions together, they need to be the same kind of fraction. So I'm going to make these both into 24ths. So to make 3/8 into 24ths, I need to multiply the top and the bottom by 3. So 3/8 becomes 9/24. And then I'm going to add on 1/24 to get 10/24. Now, if you reduced that, you get bonus points, because you could actually reduce that to 5/12. Give yourself 17 million pats on the backs if you were able to reduce that. Okay, 4 times 2/3. So, I think the easiest way to, well, there's a lot of different ways you could do this, but one way to do it is to add up 2/3 4 times. Right? That's what that means. 4 times 2/3 means make 4 copies of 2/3. So if I, well, where did that 4 come from? So if I add up 4 copies of 2/3, I get 2, 4, 6, 8/3. How many milliliters in 3 liters? So to get from a liter to a milliliter, we need to multiply by 100. I have 3 liters, so I'm going to multiply that by 100 to get 300 milliliters. Okay, last one. I threw this in here to talk about order of operations. The very first thing I need to do in this is these parentheses right here, this addition. So I'm going to write out 200 divided by 5 times 2 plus 6 is 8. Now I'm just working left to right. 200 divided by 5 is 4 times 8 is 32. Okay. So talking about logical thinking, I have a really cool problem for you. Some of you have been talking about polygons. So here's how the problem goes. A polygon, I'm going to do a hexagon. A polygon has sides. It has intersection of sides, which are called vertices. This is called a vertex, each of those little dot things. And it's called a diagonal when you connect a vertex to another vertex, but not a side. So that's a diagonal, that's a diagonal, that's a diagonal, that's a diagonal, and so on. There's a lot of diagonals in a hexagon. I haven't even drawn them all. The question is, in a hexagon, how many diagonals are there? So there's obviously so try it first. There's obviously a lot of ways you can do this. One is to just start drawing, which is fine. But if I changed this to, instead of hexagon, if I changed this to a 30-sided polygon, nobody's going to want to sit and draw all those diagonals. So I'm going to start off with a fresh hexagon over here. And I'm going to try and think logically and methodically to figure out any pattern that I can find to these diagonals. I bet you have a great idea of how to count these. Here's one idea. One idea is, I'm just going to label these A, B, C, D, E, F. Maybe that gave you an idea. If it did, pause it and figure it out. But I'm going to look at how many diagonals I can draw from each vertex that I've labeled. So I'm going to start at A. How many diagonals can I draw from A? So I can draw 1, 2, 3 from A. Because this is not a diagonal, that's a side, and this is a side. Okay, now I'm going to look to B. How many can I draw from B? I can draw 1, 2, 3. So at this point, you might be thinking, oh, they're all 3. I'm just going to multiply it. Well, not so quick. Because what happens when we get to C is that one of these has already been drawn. See that? So from C, I can actually only draw 1, 2 new ones. From D, I can draw 1, 2, 3. Sorry, I drew 1 new one, right? And then from E, I can't draw any new ones. And from F, I can't draw any new ones. So in total, I have 6, 8, 9 diagonals. Might be too low to see. 9 diagonals in a hexagon. Okay, so I challenge you to find how many diagonals. Now that you know that, how about in a pentagon? It's easier if you draw the pentagon somewhat regular. Regular meaning all the sides are the same, all the angles are the same. It's just easier to keep track. But see if you can figure out how many diagonals are in a pentagon. Okay, so if I look at each of the vertices again, from A, I can draw 2. From B, I can draw 2. From C, I can draw 1. From D, 0, and from E, 0. Look at those patterns, how similar they are. 3, 3, 2, 1, 2, 2, 1. It's very interesting. So this, you come out with 5 diagonals. Okay, so now your problem of the day is very, very similar. There are 10 people in a room. If each person in the room shakes everyone else's hand exactly once, and obviously doesn't shake their own hand, because that doesn't make any sense and you will look like a weirdo, how many handshakes will take place? So try it first, especially thinking about the problem that we just did. Okay, so one way to think of this problem is to think of it as a polygon with 10 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's not a very good polygon, but I'm just going to make sure I have 10 vertices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to label them A, B, C, D, E, F, G, H, I, J. Now, if person A shakes person I's hand, what I'm actually drawing in is a diagonal. So if you get where I'm going with this, pause it and try it before I finish it. Okay, so I'm going to write out the pattern here. Do you think by the time I get to I and J that I'm going to add on any new diagonals? Probably not, based on our other experiences. So from A, I can draw 1, 2, 3, 4, 5, 6, 7 diagonals. From B, I can also draw 7, right? From C, there's going to be 6, 5, 4, 3, 2, 1, 0, 0. Just following the pattern from the other page, right? In total, that's 14, 20, 29, 35 handshakes. I think I added that up, right? Yep. All right, that's it for that fun problem. Have a great day.